Hello students, the topic I have chosen for today's lecture is Reintroduction and Translocation. I have prepared this audio recorded PowerPoint presentation for the students of Zoology as a part of initiative taken up by Zoological Society of Assam. All of you know that reintroduction and translocation is a program of animal conservation. It is a part of wildlife management in which endangered species has been conserved through definite management goal. So, through this presentation, I am trying to explain about basic concept of reintroduction and translocation, concept of reinforcement and conservation introduction, goal and objectives of reintroduction and translocation, different steps required for success of the program like feasibility study, including habitat suitability, genetic consideration, risk assessment, release of focal species, and pre-release and post-release training, monitoring, etc. Along with these, students will also able to know about ongoing translocation and reintroduction program of rhino, swamp deer, pygmy hawk, vulture in Assam. Let us come to the concept of reintroduction. Reintroductions are attempts to return species to parts of their historical ranges where they were extirpated and might involve release either captive bred or wild-caught individuals. That means it is the process of planned release of species into the wild habitat within their original geographic range from where the species became disappeared. It has been done either from captivity or from other wild areas where the species survives. It is the intentional movement and release of an organism inside its indigenous range from which it has disappeared. That means reintroduction is a species recovery process that involves the deliberate movement and release of individual in its native range from where it has disappeared. Next come to the point translocation. Translocation is the human-mediated movement of living organism from one area with release in another. It is an effective conservation tool that involves capture, transport and release of species. IUCN 1987 used the word translocation as an umbrella term to define movement of living organism from one area with free release to another, and this definition encompasses introduction, reintroduction and restocking. Translocation is an overarching term that means it includes everything. It can be accidental or intentional. Intentional translocation can address a variety of motivations, including for reducing population size, for welfare, political, recreational interest, or for conservation objective. IUCN guideline focus on conservation translocation, a translocation that yield quantifiable conservation benefit. That's why I have written here conservation translocation is the intentional movement and release of a living organism where the primary objective is a conservation benefit. The primary objective is conservation benefit that comprise improving the conservation status of the focal species locally or globally and restoring natural ecosystem function or processes. So conservation translocation can involve releases either within or outside the species indigenous range. The indigenous range of a species is the known or inferred distribution generated from historical records, either in verbal or in written form, or physical evidence of the species' occurrence. Where direct evidence is inadequate to confirm previous occupancy, the existence of suitable habitat in some ecological pockets may be taken as adequate evidence of previous occupation. Conservation translocation within indigenous range is called population restoration. It comprises reinforcement or restocking and reintroduction. Reinforcement is the intentional movement and release of an organism into an existing population of conspecifics. The term restocking is also used for reinforcement. It is the release of the species in an area where already individuals of same species exist. Its purpose is to build up an existing population. Next is reintroduction, which already I had explained. It is the intentional movement and release of an organism inside its indigenous range, from which it has been disappeared or extirpated. That means eradicated or destroyed completely in historic time. The main aim of reintroduction is to re-establish a viable population of focal species within its indigenous range. Next point is called conservation introduction. Conservation translocation outside indigenous range is called conservation introduction. It is the release of either captive-born or wild-born animals into an area outside of their original range. It is of two types. One is called assisted colonization and other is called ecological replacement. Here in this presentation, I will concentrate on species release into their indigenous range from where populations significantly decline or disappear due to different factors. That means mainly focus on reintroduction process and related translocations for conservation of threatened species. Every reintroduction and translocation program should have clearly defined goal and objectives. The main goal of species reintroduction and translocation is to establish a healthy, genetically diverse and self-sustaining focal population to an area where it has been extirpated. In terms of conservation, such release of animal have three main objectives. First one is survival of animal after release, settlement of animals into release area, successful reproduction in the release site. Reintroduced individual may come from either captive breeding program or be translocated directly from natural habitat. And past experience showed that in reintroduction, wild-caught animals tending to be considered more successful, that is 75%, than translocation with captive bred animals, that is 38%. Any reintroduction and translocation should follow a logical process from initial concept of design, feasibility, risk assessment, making implementation, monitoring, etc. So here I am going to explain some important steps required for success of reintroduction and translocation program. The first point I have given here is the self-sustaining captive population. In previous slide, already I stated that reintroduced individuals may come from either captive breeding program or directly from natural habitat. So when reintroduction is done from a population of captive breeding center, the captive population should be a viable, well-managed, self-sustaining population with broad genetic representation. That means the population should be self-supporting population with sufficient number of individuals and genetic diversity to ensure a high probability of survival. Keeping the genetically viable population of a particular species in the captive condition is very important to preserve the necessary polymorphism within the population so that the population persists for a longer period of time. For successful reintroduction and translocation program, another important aspect need to consider is feasibility study. You know, feasibility is an assessment of the practicality of a proposed plan or method. Feasibility study covers the full range of relevant biological and non-biological factors. You should have to know that detailed studies of the behavior and ecology of free-ranging wild animal may determine a species' critical needs. So necessary information on the biology and ecology of wild populations should be collected from available publications, report, and consultation with species expert including both professional and amateur naturalists. Biological knowledge covers aspects such as reproduction, mating system, social structure and behavior, etc. Ecological knowledge covers biotic and abiotic habitat requirement, adaptation to local ecological condition, intraspecific variation, interspecific relationship including feeding, predation, disease, etc. So habitat is also an important requirement for successful reintroduction of focal species because habitat only provide entire requirement for the growth and development of the population in different life stages. It is found that principal cause of most of the species decline is habitat destruction or unsuitability of habitat. In fact, in some cases, after reintroducing a viable population in a particular habitat, the lack of suitability is the single major reason for ruling out reintroduction program. So success of reintroduction and translocation program is very sensitive to habitat quality that link to survival and reproduction rates of the species. That means suitable habitat should meet candidate species total biotic and abiotic needs through space, time and for all stages. The release area must have sufficient carrying capacity to sustain growth of reintroduced population. The release site also must be legally protected as reserves and national parks, and the protection must be effective. Another important point is the elimination of factors causing species decline. The factors that caused the species decline originally must be controlled or eliminated before reintroduction is attempted in that destination area. If the factors still exist which are responsible for elimination of the original species from that habitat, Those factors again interact with reintroduced species and never allow them to survive in that area. IUCN reintroduction guidelines also emphasize that the original cause of decline must be identified and eliminated before a species can be reintroduced to a site. Researchers must evaluate the species status, that is distribution, population size, and demography, etc., early in the program's development to identify causes for its decline. The causes of decline may be intense hunting pressure, may be predation pressure, etc. Next inevitable part of successful reintroduction is the genetic consideration of reintroduced species. The source population must be genetically diversified. A more probable problem is the reduction in genetic diversity over time. If there is a little genetic variation in source material used for reintroduction and translocation, then there is a possibility of arising two potential risks. The first is that reproduction between related individuals can lead to reduced vigor, reproductive output, and survival, called inbreeding depression. When closely related individuals interbreed, their offspring are often less fit and sometimes more less fit than the parents. This is the phenomenon of inbreeding depression. The second is a lack of adequate genetic variation to enable the survival and adaptation in the face of environmental change. Founder selection should aim to provide adequate genetic diversity to ensure a high probability of survival despite of environmental change. If the translocation program involves mixing population, there is a possibility for outbreeding depression among the offsprings. When individuals from different subpopulations brought together, new combination of mating may occur, resulting reduction of fitness of the offspring. So, too much or too little genetic variability among parents can break down the fitness of the descendants. Hence, ongoing management must be needed. Next important point is risk assessment. Risk in reintroduction and translocation is multiple. Effect in many ways: the focal species, their associated communities, and their ecosystem function in both source and destination areas. There are also risks around human concern. Any translocation program bears risk that will cause unintended damage. Risk is more when animal is released outside its range. The main categories of risk around the translocation are risk to source population. Be careful when removing individuals from source population during translocation program, because when more animals were removed at a time, it may affect the source population. Next, ecological risk. A translocated species may have major impact at its destination on other species and on ecosystem functions. Its own performance may not be the same as at its origin from where it is collected. Next important risk is disease risk. As no translocated organisms can be entirely free of infection with microorganism or parasite, so there is a risk of spread of their disease to other animals in destination area. So at the planning stage, disease risk assessment should start, and management of disease and pathogen transfer is very important to maximize the health of translocated organism and to minimize the risk of introducing new pathogen to destination area. Next point is socio-economic risk. It includes risk of direct harmful impact on people and their livelihood from released organism in and around reintroduced area. So care should be taken to avoid this type of consequences. Any proposed translocation should have a comprehensive risk assessment with a level of effect appropriate to the situations. Where risk is high or uncertainty remains about risk and their impact, it should not be proceed. Another important point is the release of focal spaces. Translocation including highly suitable area sometimes may fail due to poorly designed release. So choice of release site is very important. Release site should meet all practical needs for effective release with least stress for the release organism. All the release should be within the historic range of the species. The release area for an initial reintroduction should have either no or a very reduced resident population. That means the existing wild population, especially if the wild population is severely endangered. The individuals from captives may carry disease agents to which they are immune. But the wild individuals present in the release site may not be immune to that particular disease coming from outside. It seems always more sensible to carry out multiple reintroduction at several sites rather than to rely on a single reintroduction. Release should be done either simultaneously or sequentially at multiple sites. During the process of translocation, the animal is going through various stress at any stage, like during capture, handling, transportation to release site, veterinary examination, at the time of release, adaptation to new environment, confining unfamiliar individuals in close proximity, being maintained by humans, etc. So minimizing stress during capture, handling, transport and pre-release management will enhance post-release performance. Animals in source population may suffer stress if the removal of individuals disrupts established social relationship. Animals have social bond between different individuals in a group. If some of animals removed from the group, they feel disturbed. Various management interventions and support before and after release can enhance the performance of the individuals. So every effort should be made to reduce stress or sufferings of the individuals. One most important aspect of reintroduction and translocation is the pre and post-release training of focal animal. Most reintroduction programs have involved no preparation of the animals before release and no training once the animals are free. This strategy has been termed as hard release. When an animal is maintained in an enclosure constructed in the release site and is released after a period of acclimatization is called soft release. In case of soft release, animal will get time to acclimatize in the new habitat, getting familiar with the habitat before going to complete free-ranging condition. Soft release is preferred over hard release since a comparison of the result between these two methods shows higher survival rates and behavioral benefits for animals that are soft release. There are 6 major areas of behavior to consider in the development of any training scheme. To survive, candidates for reintroduction must be able to avoid predators, to know how to acquire food, to interact properly with conspecifics, to find shelters or construct nests, to locomote on complex terrain, orient and navigate in a complex environment. That means adapt to a complex environment. After release of species, monitoring program must be performed regularly. That include to see the performance of animal in new habitat. Monitoring using modern technique and follow-up are important for reintroduced animal. Post-release monitoring include demographic monitoring, which include monitoring of population growth, individual survival, reproduction, and dispersal. Next is ecological monitoring, that include assessment of ecological impact arising from translocation, and also should have to be assessed and determine whether it is beneficial or harmful. Next is behavioral monitoring, mainly include activity and movement pattern of translocated animals, foraging behavior and diet selection, social organization, breeding season, and success. Next is genetic monitoring. Monitoring can be used to assess genetic diversity in establishing reintroduced population. Next is the health and mortality monitoring. This includes assessing at what extent an establishing population is experiencing disease or adverse welfare condition or mortality. Socio-economic and financial monitoring. Socio-economic and financial impact of any translocation should be monitored. It includes assessing the attitude and perception of local communities towards the reintroduction and translocation program, and any economic benefit and cost, either direct or indirect, arising from this program. Next point is habitat protection and restoration. Management of land and even the restoration of destroyed habitat is important for reintroduction program, which is a part of comprehensive conservation effort for endangered species. In many cases, it has been seen that most of the habitat has been changed during the process of ecosystem succession and due to some degradation process. So for the conservation of target endangered animal species, degraded changed habitat should have to be restored. In case of this program, education and public relation is also required. A reintroduction cannot ultimately succeed without the researcher interacting with local and national government, government and non-government professionals, and the public. For success of reintroduction and translocation program, long-term commitment is needed. At last, this program should be fully documented and outcome must be made available for public, conservationist, educationist, and as well as government decision makers for future conservation planning. From 1990 onwards, lots of changes have been occurred, both in the level of habitat and as well as in species status. And Some of the commonly found species even converted into endangered and critically endangered. So, different reintroduction and translocation programs have been initiated in Assam for the conservation of those important species. Now, I would like to tell about those ongoing programs of Assam. The first program I like to mention is the translocation of rhino in Manas National Park. During 1990s, rhino was extinct from Manas. For the conservation of globally known one-horned rhinoceros in Assam, Government of Assam constituted the task force for translocation of rhino within Assam called as Rhino Task Force in 2005. It received immediate support from two international organizations like WWF and International Rhino Foundation to undertake activities for conservation of rhino in Assam and to create new population in Assam through translocation. The task force set a vision named IRV 2020, Indian Rhino Vision, to increase rhino population of 3,000 in the wild in Assam in 7 of its protected areas by the year 2020 from present population through the process of translocation. Under IRV 2020, altogether 20 rhinos were translocated to Manas National Park from Kaziranga National Park and Pobitora Wildlife Sanctuary, that is wild to wild release, 10 each from both the habitat starting from 12 April 2008 to February 2020. Rhino translocated by Center for Wildlife Rehabilitation and Conservation from 2006 to 2019 is 17 in number. Early in 2006, WTI partnered with BTC reintroduced one rhino in Manas from Kaziranga. This was the first rhino to reach Manas after the resident population of rhino had been wiped out due to different factors. All the rhinos translocated by CWRC are released first in the pre-release center called BOMA. It's an enclosure surrounded by solar power electric fence before release in wild. All rhinos are radio collared to enable post-release monitoring, and all valuable data are collected like habitat use, range extension, social interaction with conspecifics, etc. The collars are either dropped on their own or made to drop using a pre-programmed device. Total 37 rhinos were translocated from Kaziranga National Park and Pobitora Wildlife Sanctuary to Manas National Park, and total calf born there are 23 in number. But due to poaching, 10 numbers and disease 7 numbers, total 17 rhinos were died. At present, total rhino present in Manas National Park is 43 in number. These photographs show the officials and members of CWRC at the time of rescue operation during flood at Kaziranga National Park. Here you can see the rhino cubs rescued by them. CWRC, established in 2002 at Kaziranga, initiated by Assam Forest Department in collaboration with Wildlife Trust of India. The center has been providing all rescue and rehabilitation needs of wild animals, mainly in Kaziranga National Park, and at present, center handled more than above 3,500 animal rescue cases and more than 50% of these animals were successfully released into the wild. Our next program is the translocation of swamp deer in Manas National Park. Swamp deer, Rucervus duvauseli, is listed in IUCN Red List as vulnerable, and it has three subspecies. One is called northern swamp deer, Rucervus duvauseli, distributed in Dudhwa National Park, some terai forest of Uttar Pradesh and Uttarakhand. Second one is called central swamp deer, Rucervus duvauseli branderi. It is also called as hard ground barasingha, found in Kanha National Park in Madhya Pradesh. And third one is eastern swamp deer, that is Rucervus duvauseli Ranjit Singhai, found in Kaziranga National Park. So here I am talking about the translocation of the eastern swamp deer from Kaziranga to Manas. The major part of this population is present in Kaziranga National Park, and there is a small population of swamp deer surviving in Manas, but no estimate was available. Thus, a project was conceived to restocking this species in Manas National Park from Kaziranga. There was a need to build up remnant population to secure the future of the species, because viable population of these species is only found in Kaziranga National Park. This translocation project was initiated by a team expert from Wildlife Trust of India, Assam Forest Department, College of Veterinary Science, Khanapara. Local communities around Kaziranga National Park and Manas National Park and BTC all came together in support of restocking project. In December 2014, first stock of 19 individuals were released, and second stock was released in February 2017, having 17 number of individuals. First, all are released in the Boma. After that, they are released in natural wild habitat of Manas. So total number of 36 individuals of swamp deer are translocated from 2014 to 2017 from Kaziranga National Park to Manas National Park. Here you can see the eastern swamp deer release Boma in Manas. And at present, a total of 99 individuals of swamp deer are recorded as per latest report in Manas National Park. Next come to reintroduction of pygmy hawk. Pygmy hawk Porcula salvania is the smallest and rarest wild shuit in the world, and the species is listed in IUCN Red List as endangered. Historically, it was known to found in a narrow strip of tall and wet grassland plains in the area south of Himalayan foothills from Uttar Pradesh to Assam, through Nepal Terai and Bengal Duars. After at least 2 decades, no report of sighting was found, and in 1971, it was rediscovered in 2 separate locations in northwestern Assam, namely Bornodee Reserve Forest and Manas National Park. Subsequent field survey also confirmed its continued occurrence in several other reserve forests in northwestern Assam in the late 1970s. But continued commercial forestry operations resulted in its extirpation in all of those areas by the early 1980s. Extensive survey in the late 1980s and early 1990s failed to locate any other surviving population of this species in all those former ranges except only a few locations in and around Manas National Park. So for conservation purpose, pygmy hawk conservation breeding program was started in Basistha from March 1996. Captive breeding program of pygmy hawk was first initiated in 1996 by Assam Forest Department and Ecosystem India, headed by Gautam Narayan in Basistha, Guwahati, by capturing 2 males and 4 female hawks from Manas National Park. In 2004, a large pre-release center has been established in Potosali, Nameri Tiger Reserve. After successful breeding, the hawks are reintroduced in 3 protected areas of Assam, that is Sonai Rupai Wildlife Sanctuary, Orang National Park, and Bornodi Wildlife Sanctuary. Currently, pygmy hawk is restricted to a single viable population in the wild in Manas Tiger Reserve and 3 reintroduced populations in Sonai Rupai Wildlife Sanctuary, Orang National Park, and Bornodi Wildlife Sanctuary. Presently, pygmy hawk conservation program has been undertaken by TSRP, which is the Threatened Species Recovery Program, which was established in 2018 in the aegis of partnership between Durrell Wildlife Conservation Trust and Aranya. It is a collaborative project of Durrell Wildlife Conservation Trust, IUCN SSC Wild Pig Specialist Group, Aranya, Ecosystem India, Forest Department Government of Assam, and Ministry of Environment and Forest Climate Change Government of India. These 3 photographs show the release operation in Orang National Park. First one shows the project team near release enclosure. It shows the hog being released in Orang. It shows the radio tracking of released hog. This photograph, you can see hog being released at Sonai Rupai. These 2 above photographs show the capture operation in Manas Tiger Reserve. Since the size of initial founder population was very small, only 6 in number in captive breeding center Basistha, so plans were made to capture some more hawks from Manas in order to improve heterozygosity and survivability of hawks. And in 2013, 3 more hawks were captured from Manas Tiger Reserve. Here you can see nets were deployed for capturing purpose, and here captured wild hawks are kept in bags. Current population estimation in Manas shows 200 wild. About 60 to 70 hawks are maintained and bred in captivity. 116 captive breed hawks have been successfully reintroduced in wild in 3 protected areas of Assam since 2008. Next come to reintroduction program of vulture species. Vulture program have played a major part in the greater acceptance of reintroduction. Most of the vulture species in the world are now undergoing population decline. Some of them catastrophically have declined during 1990s to 2000s, as in the case of 3 species of Gyps vulture, Gyps bengalensis, oriental white-backed vulture, Gyps indicas, long-billed vulture, and Gyps Tenuroistris slenderbill vulture, from being the most abundant birds of prey on the Indian subcontinent to critically endangered. Out of 9 species of vulture found in India, 6 species of vulture are found in Assam. Out of these 6, 3 are considered to be critically endangered. Mainly 2 vultures of Assam, Gyps tenuroistris and Gyps bengalensis, are now 97 to 99.9% decline and almost slipped to extinction due to incidental poisoning by the non-steroidal anti-inflammatory drug diclofenac, which was widely used across South Asia to treat livestock. It is given to livestock as an anti-inflammatory drug. If the animal dies within 72 hours of being treated with the drug, the carcass still contains dangerous level of this drug. These carcasses are the primary food sources for the gyps. Now, the drug is banned by the government, and meloxicam is the safest drug suggested by veterinary doctor as an alternative of diclofenac. Still, people are using it. Diclofenac is highly toxic to gyps vulture. For the conservation of 3 critically endangered gyps species, vulture conservation breeding program was started. And in Assam, it was started from April 2007 at Rani for the conservation of slender-billed and white-backed vulture by the initiation of Bombay Natural History Society and Assam Forest Department. These are different types of aviaries for breeding, nursing, and housing vultures constructed at Rani. Main objectives of the Rani Center is to establish a founder population of 25 pairs of each of 2 species of vulture, that is white-backed and slender-billed vulture. To produce a population of at least 200 birds in 15 years of each species to be reintroduced to the wild. Apart from Rani Center, 3 other vulture conservation breeding centers are in India, which are in Haryana, West Bengal, and Madhya Pradesh. At present, there are altogether 120 vultures in captivity, of which 50 individuals are born in captivity at Rani Center. Newly fledged are ready to reintroduce to the vulture safe zone called VSZ from 2020 onwards in a group of 10. VSZ is a circular area of about 100 km radius to be made safe for vultures for various identified threats such as non-steroidal anti-inflammatory drugs and other poisons. The center of the VSZ in Assam is Majuli and also covering Golaghat, Jorhat, Lakhimpur, Sibsagar, Dibrugarh, Dhemaji, Karbi Anglong, Nagaon and Sonitpur district. Morigaon and Kamrup districts are also part of this program, though these 2 districts are slightly outside 100 km radius, but historically had a good vulture population. In order to declare an area a VSZ, there is need for government support, awareness activities among local stakeholders and periodic monitoring through sample testing of animal carcasses for detection of presence of veterinary drug toxic to Vulture. For release purpose, now the center has initiated vigorous awareness program against drug diclofenac and poisoning of carcasses by using pesticides in safe zones, so that after release people are involved for the protection of critically endangered vulture and they can build up their natural population. These are the references which I have been going through during the preparation of the presentation. Some references I have given here also, and I would like to acknowledge Professor P.K. Saikia from Guwahati University, Dr. Bibhav Kumar Talukdar from Aranya, Dr. Sosin Ranade from Vulture Conservation Center, Dr. Dritiman Das from Pygmy Hop Conservation Center, and Mr. Nazrul from Guwahati University, who have helped me a lot by giving some recent data related to my presentation. Here I have given my email ID, that is malavika8370 @gmail.com. Your feedback is most welcome. Thank you so much.